Today's lesson is very short but very important. And the notes in your notes about today's lesson is this big. It's all about the graphs of f, the first derivative, and the third derivative. Now this that I have here is not on your notes. So either write it down or wait for the video and then you just pause it while you watch it again. No. It depends on what you want to write down. Okay, first listen. Okay. Let's say I give you that cubic function. What form is that? Positive or negative? Positive. So it's a positive cubic function. If you take the first derivative, what type of function is that? Parabola. And is it positive or negative? Positive. If I take this one and I differentiate that, so I get the second derivative, I get this. And that will be a straight line. Also positive. Okay, so the first thing that you need to see or realize is if I take the function of a cubic function and I get the first derivative, it's a parabola, also a positive one. And if I differentiate this parabola, I get a straight line, also a positive one. The same goes for negative. Are you with me? The negative cubic function, if you differentiate that, you get a negative parabola. If you differentiate that, you'll get a negative straight line. Okay. Now let's quickly recap it in one page. The cubic function has two turning points. Brooklyn, are you with me? And the formulas for the turning points are the first derivatives set to 0. If I differentiate that, I get the parabola. But what is the parabola's x-axis values? How do you get that? You set the parabola equal to 0 to get the x-axis. The x values. X-intercept, sorry. Yeah, I'm thinking about that, but I say the wrong word. So, if you set the parabola equal to 0, you'll get the x-intercepts. But now, look, this formula is the same as that formula. Can you see? So actually what happened here was the turning point's axis is also the same as the parabola's axis on the x-axis. What intersects? The intersects. Okay. How do I get the parabola's turning point? I have to differentiate this and set it to 0. I did the same here. How did I get the turning point? I took the function and got the first derivative. So now I have the parabola. It is already a first derivative, so I have to differentiate it again, set it to 0 to find the turning point of the parabola. Are you with me so far? Okay, what happened now? If I differentiate this again, I get the straight line. And where is the straight line's x-intercept? It's where this is equal to 0. So, the turning point of the parabola is also the x-intercept of the straight line. Okay, so do you follow from the top to the bottom? The x values of the turning points form the x-intercepts of the next graph. The turning point of the graph forms the x-intercept of the next graph. Alright. Okay. So what you should realize is that the turning point, the x value, is the same as the x-intercept of the next graph. And the turning point here, the x value, is the same as the x-intercept of the next graph. Okay. That's what you should know for today's lesson. Okay. We're not done now. Okay, we have to wait a little bit. It's still recording. Let's just recap with the graphs on top of each other. If we have the cubic function and we get the x values of the turning points, that will be the same as what? Yeah, the x values of the intercepts. So the x of the turning point is the same as the x of the intercept. Now we also have a turning point here. So this x will be the same as the straight line's x-intercept. And this picture you have on your notes.
Yes. Is the turning point and the x-intercept of the straight line also equal to the point of inflection?
Can she say that at all?
This turning point's x value is the same as the x-intercept of the straight line, but it's also the same as the x value of the point of inflection. Alright, that concludes the lesson for today. Very short and sweet.
Thank you. That was Miss Tanya for the assignment.
Your homework for tomorrow, thank you. Yeah. Actually, your homework for Sunday afternoon.
I'm glad you
We did the graphs of f, the first derivative and the second derivative. Your homework is exercise 9. I'm not sure whether yours will be on page 40. 38. So it's numbers 1 to 3.